So we have started to discuss about TCP/IP, how data transmission is happening from one device to another device. Like one universal protocol is being developed, which is TCP/IP. So how TCP/IP is working in 1984, ISO is developed one reference model, which is OSI. Like OSI consists of 7 layers, which is application, presentation, session. The top 3 layers we call the software layers or user support layers. Transport layer, core layer of OSI, and bottom 3 layers, which is network, data link, and physical layer. Hardware layers, or we can call it as a network support layers. So each and every layers we have a set of functions, set of rules is there. We clearly discussed about application. Application layer is a interface between the user to interact with a services. Every services is being identified by port numbers. And presentation layer is the responsibility of providing standard format to the data, like encoding, decoding, encryption, decryption, compression and decompression, these things. Next, a session layer. So session layer is the responsibility of like interaction, like establishing the sessions, maintaining the sessions, and terminating the sessions. These all are taken care about by session layer. The transport layer has a major functions has been described, like so transport layer has a mechanism of data delivery mechanism. So what is the responsibilities of transport layer is identifying surveys. It's a TCP or UDP. If it's a TCP, three-way handshake process. Sending acknowledgements, communication is reliable. If it is UDP, no three-way handshake process, fast communication. In TCP three-way handshake process, what is the first packet?
Sin.
Synchronize.
Yeah.
Okay. Second packet?
Acknowledge. Synchronize and
Synchronize
acknowledge.
acknowledgement. Third packet?
Acknowledge.
Acknowledgement. So once three-way handshake process is done, now connection is established between the like your sender, source and destination devices. Yeah. After identifying service and transport layer responsibilities are multiplexing and demultiplexing, segmentation, sequencing, reassembling, error corrections, flow control. These all are transport layer responsibilities. Like up to transport layer we have discussed, right? So today we continue with remaining bottom 3 layers, which is hardware layers. Before that, data flowing from application. Application to presentation, presentation to session, session to transport. And what transport layer will do? Yeah, and data is flowing from application, right? Presentation, session, session to transport. What transport layer will do? We'll send it to next layer is what? Network layer, right? Now data is under which layer?
Network layer.
Network layer. Okay. So here have one question, guys. Out of 7 layers, which layer is the responsibility of identifying the service?
Transport.
Transport layer can identify the data is belongs to which service, right? Is it TCP or UDP? Like what is the protocol? So transport layer can identify it because of it has a mechanism. It has the responsibility of identifying the service. Okay, transport layer knows about that data is belongs to which service. Network layer don't know about data is belongs to which service, right? But data is now under network layer. So what network layer is telling is that like I don't know. So this data is belongs to which service? The network layer is dropping the traffic. If network layer is dropping the traffic, then how we can have a proper communication? So what transport layer is doing is before sending a data to next layer, so transport layer is adding some headers. It's adding data plus transport headers. TH. Is adding what? Transport header. So data plus transport header, both we call combinedly we call it is a segment. So your data is being the form of segment. In transport layer, segments has been generated. So what is a transport header contains information is data is belongs to which port number, like your source port number, destination port numbers, source port, destination port number, and TCP UDP information. This data is comes under TCP or UDP. So these things will be there in transport headers. Data plus transport headers is what? Segment. So this segment is being sent next layer is what? Network layer. Segment is under now network layer, right? Yeah. Network layer is layer 3. Data link layer, layer 2. Physical layer, layer 1. Like bottom 3 layers are hardware layers. Network support layers. Like why we call it as a hardware layers? Hardware devices comes under these layers actually. Like what are the devices that are required to form a network to forward the data traffic is like two different network communications to enable we require a router. So that router becomes under network layer. So network layer device is layer 3 device is a router. So router will works with IP address. It can understand IP address. So the data traffic is coming from which IP and where to reach, like source IP, destination IP. Based upon the source IP and destination IP, router will forward the traffic. Like router can understand IP address. It can be IPv4, it can be IPv6. So based upon IPv4, based upon IP address, it can be forward the traffic. So IP address also comes under network layer. Layer 3 address is IP address. So transport headers plus data is segment. Next layer network. It provides logical addressing, IP addressing, and path determination means routing. The network layer have a two protocols. In network layer, have two protocols. One is routing protocol. Another one is routed protocol. What is routing protocol and routing protocol? See this diagram here. This is my router. Say router A is connected to router B, router C, and router D. B is connected to H E F like G. Some routers are connected. Yeah. Now A is my local network, means head office. H is my branch office. Branch office 1. Now let's consider from head office how to reach branch office 1. We have the path 1, first path, route 1, path 1, path 2, path 3. Like A to B, B to H I can reach. This is one route. What the traffic is coming from the LAN users, LAN to router A to B, B to H. This is one route. Or LAN to A to C, C to E, E to F, F to H. This is second route. And third route, A, D, G, H. So from source to destination, we have a three routes, right? Three paths is it. So out of three paths, which one is a best path? ABH or ADGH or ACEFGH, which is a best path?
Shortest one, ABH.
ABH is a best route. Okay. Now A to B, this overall link speed is like A to ABH. This overall like link speed is, let's consider, say 10 Mbps. Now ACEFGH, this overall link speed is a, let's consider 80 Mbps. And here link speed is a like 100 Mbps. Now tell me source to destination, which is the best path? ABH is the best, or 80 Mbps link is the best, or 100 Mbps is the best link?
Mbps. Obviously, it is D and G, the 100 Mbps.
100 Mbps link. So before you have decided the best route based upon the number of routers to reach a destination, right? Yeah, ABH is a only two routers has to be crossed, so shortest path that is the best route. But now you are deciding based upon the bandwidth, based upon the speed. Yes. So in the real time also, like how we can find the best path means not only the based upon the number of routers, we need to be included a lot of parameters. So number of routers is one of the parameter, and bandwidth is one of the parameter. Like how much traffic in the link is another parameter, and how much reliable is there. Any packet loss in the link is there or not, and what is the packet size, and how much security or link. So a lot of parameters will need to be included, and finally have to find the best route. But that headache we don't require actually. Like as a network administrator, we don't need to be bothered about it. You know why? Because in all routers, if we configure these protocols, routing protocols, if enable, so if we configure routing protocols, then routing protocols will automatically find the best path based upon their algorithms. So routing protocols are being designed for find the shortest route to destination. Routing protocols, best path selection. Examples of routing protocols are routing information protocol, RIP, OSPF, EIGRP, like we have so on, so on, etc. These are the routing protocols, guys. Clear? So routing protocols used to find best route to reach destination. So as a network admin, what our task is, implement a routing protocol and routers, configure routing protocols in your routers, then protocols will find the best route automatically. Okay,
Small and more question.
yes, please.
And these protocols that you're talking about, that RIP and OSPF and EIGRP, are all these proprietary protocols for Cisco, or they are all universal protocols?
All are universal protocol, open standard protocols. Even RIP, OSPF, EHRP. But EHRP, it was a Cisco proprietary, but now it is open standard protocol.
Thank you.
Yeah. So routing protocols, finding a best route. Let's consider, as per routing protocol, best path is a ADGH because of bandwidth, right? Like A to
100
D, yeah, D to G and G to H.
Mbps.
This is a best route because of 100 Mbps.
100 Mbps.
Yes, based upon routing protocol. Okay, best path is being selected. Means the route is defined. Route is defined. Now, from LAN users, data traffic is generated, right? This data traffic, we have a ready. What is ready is a route is ready. But a data traffic has to be forwarded. So data traffic has to be carried from source to destination. The data carriers as required. So your data is being carried through best route is possible with the help of routed protocol. Routing protocol will find the best route. Routed protocol will carry the data carriers. So your data is being carried from host to host. One device to another device is in the back end. A protocol is working. Which protocol? A routed protocols is there. So routed protocol is to carry user data between the hosts. So examples of routed protocol is IP, IPX, AppleTalk. These all are routed protocols. So IPX is a proprietary, like a novel. AppleTalk is a proprietary. So Apple devices. Like IP is open. TCP IP. Like IP is open standard. Any protocol will be working. So anyone. So generally we call IP address, right? What is IP here? IP is a, yes. What is IP?
Internet protocol.
Yeah. Its standard is internet protocol. Okay. Full form is internet protocol. But what is that? What is exactly that? What the functioning? What IP will do?
Logical address.
Carry the data.
That is a very important point, Anand. Very good. So IP is a routed protocol. IP is a routed protocol. What routed protocols will do? So routed protocols carry user data. So means from your device, like which protocol is carrying the data to another device? IP is there. So address for what purpose? Identification purpose. So why we call it is IP address for data carrier and identification, like both we call generally IP address. So to enable communication, IP address is must. Okay. So these protocols comes under which layer is a network layer, layer 3. So layer 3 device is router. Layer 3 address is IP address. Layer 3 protocols are layer 3 protocols. What are the layer 3 protocols?
RIP, OSPF.
These all are layer 3 IP, RAP, OSPF, EHR. Simply can say routing protocols and routed protocols are layer 3 protocols. Okay. Yeah. You can read this point. So data flowing from application to presentation, presentation to session, session to transport. So transport layer is adding headers, transport headers. Like inside the transport headers, we can get source port, destination port, TCP, UDP information. So combinedly, we call it as a segment. Segment comes to network layer. Now network layer is also adding headers to the segment. There is network headers, NH. So segment plus network headers combinedly, we call it is a packet, IP packet. Then what is the network header contains? So network header contains about the source IP address and destination IP address information will be there. Source IP, destination IP. This thing comes under network header. There is a packet. So packet will comes to data link layer. It's clear? Yeah. Now IP packet analyzation. What is packet contains? What is IP packet contains? Please tell me. If you break the packet, if you open the packet, what information you can get?
Network information, transport layer
Source
information,
and
and data.
So
source and
network header
destination.
contains is what?
Data and
Segment plus network header is a packet, right? Yes. Network header segment is a packet. So if you break the packet, we can get network header and segment. All right. So if I open network header, then what information you can get?
Source and destination IPs.
Source IP address and destination IP address. Like who is sender, where to reach that information also. Then what is the segment contains?
Transport header and data.
Data plus
PH.
transport header. Yeah. So if I break this transport header, then what information you can get?
Source source and destination like protocol TCP
Protocol,
namespace.
source port and destination port number, TCP, UDP. These information you can get in transport headers along with your data. Means yeah, is the text or is the images, what your original data, we'll get it actually. So these all the information contains the packet. So if you open the packet, they can come to know source port, destination port, and source IP, destination IP, and along with your original data is all information contains what? IP packet. It's clear? Yeah. So transport layer is adding transport headers. Network layer is adding network headers. So there is adding headers. Adding headers. This process we call encapsulation. Encapsulation is a process of adding headers and trailers to the data. Data encapsulation. Okay. Data encapsulation is a process of adding headers and trailers to the data for proper data transportation purpose. Right. Next layer is a data link layer. Which is layer 2. Data link layer, majorly data link layer responsibility is what here it is. MAC address. So what data link layer will do, it provides reliable transit of data across a physical link. It also provides error detection by using a CRC, cyclic redundancy check. Now data flowing from application to presentation, presentation session, session to transport, transport to network, finally network to data link layer. Whenever data received to data link layer, you know what data link layer will do? So it's going to check the data has any errors or not. So final checkup. You can say before leaving the computer, it is going to check whether any error is being there in the packet or not. It's going to check that actually. Error detection, like how data link layer will error detect that? So data link layer will use one protocol called CRC, cyclic redundancy check. So by using the CRC, is going to finding errors. If data has any errors, it is found in one error. Yeah, so on some data packet have some error. Now data link layer will not correct it. It's just a mechanism of detection, error detection. Now you know what data link layer will do? Will send this data packet to transport layer. So transport will correct it and again we'll resend to network to data link layer. It's a method guys happening in your data link layer. So data link layer used to also provide error detection by using what? Cyclic redundancy check. So whenever data received to data link layer, it implements CRC, it finds any error, send to session, send to transport. If there is no error, then normal processing. So packet is being received to data link layer. What data link layer will do? Data link layer also is adding headers and trailer, header and trailer. So data link layer is adding data header and data trailer both, DT and DH. Data trailer contains CRC, cyclic redundancy check protocol. Data headers contains source MAC address and destination MAC address. Because of in data link layer, it is a layer 2. The device comes under data link layer is switch. So switches are layer 2 devices. So how switch can forward the traffic? So switch cannot understand the IP address. So switches can forward the traffic based upon the MAC address. Source MAC, destination MAC, based upon MAC address. And what layer 2 will do? I mean data link layer will do? Error detection. For that it use what? CRC. So this is data trailer, CRC, data header, source MAC, destination MAC, data trailer, packet, header. These all combinedly we call it is a form of frames. Frame is generated. See, have you seen like how your data has been changing? Segment to packet, packet to frame. No? So this is what happening in data link layer, guys. And frame will comes to physical layer. So what is a physical layer? Is a layer 1. Finally, frame is being converted to bits. So this is a process of data communication, segment, sequencing. See, sequence. What is sequence? Segment to packet, packet to frame, frame to bits. Now let me explain what exactly happening in a physical layer. Yeah, what is our yesterday example we discussed? Yesterday example. Pradeep, PC and Anand device, right? Okay. Now,
Proto
Yeah, Pradeep, are you using what type of internet connectivity are you using? Like how you are using internet? What is the media? What is the media you're using? Wireless or wired?
Wireless.
Wireless, okay. So your PC is connected to Wi-Fi device. What about Anand?
Wired.
Wired, okay. Or a connected internet through via service provider. Through wired, right? Even Pradeep, you are also from your Wi-Fi router, you're connected to wired, right? Yeah. So source is Pradeep. Destination is Anand. Now Pradeep is sending some message. What is that? Hi, hello. So to send that message, first thing you require what? Application layer will come in the picture. And what application layer will do? It's just an interface. App is what? Interface user to interact with services. The next is a presentation layer. What presentation will do based upon type of data is provided standard format. So your data is being format is what? .txt format is there. Now session layer is going to establish a session between the source and destination devices. And the transport layer will do what? So transport is going to identify what type of service are you using. You're using TCP or UDP. If it's a TCP, three-way handshake process. If it is UDP, faster communication. And if data size is a 5 MB, more than 5 MB file is being segmented and providing sequence numbers, reassembling, this all comes under transport layer, right? Okay, transport layer is okay. But what transport layer will do before sending to network layer, your hi hello data packet is being converted what? As a segment.
Segment.
Exactly. The form of segment in transport layer. Now next one is a network layer. So what network layer will do? From source to destination, if you have a multiple paths, more than one path, then what network layer will do? In network layer, protocols, layer 3 protocols is there, like RIP, OSPF, EHRP. These layer 3 protocols will find the shortest route to reach a destination. An IP protocol, IP is what IP will do? It's a carry the data, right? So this thing comes under network layer. Now what network layer will do? The segment is adding by adding a source IP, destination IP is a form of packet is being generated. Packet. Now data link layer will implement CRC to detection the error. Like if you have any errors in the packet or not, like it's check what implement what the CRC error detection. If there is no errors, then everything is okay. So what data link layer is doing is adding also headers and trailer. CRC and source MAC and destination MAC. The form of what? Frame.
Frame.
In physical layer. In physical layer, media will come
Bits.
in a physical layer, cables, right? So
Mm.
means bits.
But
Yeah. Bits means what? 0 and 1s, right? So finally, what exactly happened to your hi, hello message? Or your images, or your audio, or your video, whatever data? Finally, what happened? The
Broken
form
into
of what?
small pieces.
Zeros and ones. So your data, your original data is being the form of zeros and ones finally. So that way is this is the way actually. The how means like to presentation and session, transport, network, data link, and physical layer. Finally, your data is in zeros and ones. Okay, after zeros and ones, what type of media we are using? Based upon type of media, your bits has been converted to signals. Like what type of media we have is RJ45, which is copper cable, copper media. It is a wireless media. and service providers will use optical fiber cable. So mostly we have this the media actually, copper, wireless, and optical fiber. Okay. Now, so Pradeep, you are using wireless media, right? Yes.
Yes.
Yeah. So if you type hi, hello, will come to segment, segment to packet, packet to frame, frame to bits. And what is the media using? Wireless. Then your bits are being converted as a RF signals, radio frequencies. Because of you're using what? Wireless media. So based upon type of media which you are using, your bits are converted to signal based. If it's a copper media, if you are using a wired, like Anand, if you are using a wired, then your bits has been converted as a electrical signals in different voltages. Electrical signals has been converted. So service providers, like all customers traffic will come to service provider. All customers traffic will come to a service provider. Now service provider to another service provider, like one state to another state. Like what service providers will they use? So they use what? Optical fiber cable. So means your signals is again converted as a light pulse. Different wavelengths. Different wavelengths has been converted. So in physical layer, what exactly happening based upon type of media which you are using, bits are being converted to signals. Copper media, electrical signals, wireless media, radio frequencies, optical fiber media, light pulse, like this. So this is exactly happening in physical layers. Okay. In physical layer, data into signals based upon type of media. Is a copper media, electrical signals of different voltages, fiber media, light pulses of different wavelengths, wireless media, radio frequency waves. Okay. It's clear.
Yeah, clear. Balu, what will actually, who will convert this into bits and ones, bits and send it as a signal, meaning which component?
Media, layer one.
You meaning you say that the NIC card,
Yes.
if I'm having a computer, if I'm using a NIC card and the NIC card will do that, or how actually?
It's a functioning of TCP/IP. So the mechanism is in TCP/IP protocol. See, these are all
Okay.
functioning like a data link layer function, routed protocol, routing protocol, TCP, UDP, sessions and presentation and services, and this signal conversions like copper, media, electrical, is all comes under TCP/IP stack. TCP complete one package actually, TCP/IP. So what this
Okay.
protocol will do, like based upon type of media, it'll convert it to signals. So there is no specific component like we have to convert like to the signals and like this action. This all comes under TCP/IP.
Thank you.
Yeah. So the mechanism is the mechanism is under TCP/IP, but this is your computer, and you have a physical port, an IC card, and you have a computer which is WNIC, and you have a computer which is NIC are connected to ISP network. ISP network is connected to with optical fiber cable. In first case, data is being generated. The data to convert to the signals, the mechanism is in TCP/IP, but what is the component here? We have physical NIC, right? So means which cables are connected here? Copper wires. So copper wire is connected. Now what your NIC will do here means NIC also like TCP/IP program is there, right? So what NIC will do? Yeah, I am connected through white. Then what are the bits is what are the signals is coming? What are the zeros and ones are coming? So that bits has been converted to electrical signals and passing to one copper wire. Because of copper wire is connected to NIC now. So electrical signals. Same day, similarly next computer, like here data zeros and ones, and I'm not connected to wired. So inbuilt of your computer has what? Wireless NIC cards. So it has to transmission the data. Even the wireless NIC also, there is a program. In that program, we have what? TCP/IP will be there. Like what TCP/IP will we do? The mechanism is what? Send it to radio frequency waves. Here we have the physical NIC, and all the data will go with a electrical signals to service provider. Now service provider using the modules what? Or optical fiber modules. So in that light signals will be passed. Okay, based upon what is the medium and what is the port types are using based upon that. So this is all about TCP/IP stack and OSI reference model. How data flowing from one device to another device. Okay, and in source side, this is the happening, guys. In source side is adding a transport headers, network headers, data header, and data trailer. Is adding in the form of segment, packet, frame, bits to signals. We'll consider here radio frequency waves to ISP, ISP to light pulse to destination is Anand. Anand is using what? Wired, means electrical signals to Anand device. And finally come to again what? Bits, zeros and ones. And zeros and ones are converted to again what? Frames. Will come as a frame. And what is the frame contains? Data headers and data trailers. So the data trailer has been removed. Data header has been removed. In the form of what? Packet. In the packet, network header is there. The network header has been removed. Then is a form of segment. Segment will remove the transport header. The data come to session to presentation, presenter to application. You can get the message hi, hello. So adding headers is encapsulation. Removing headers is decapsulation. So finally, data communication has been happening The process is what? Data encapsulation and decapsulation method. Okay. Is adding headers, segment, network headers, packet, header and trailer, frame to bits. Encapsulation and decapsulation. Adding headers, adding headers, adding headers. Says encapsulation method for host A source. Now, what type of media are you using? Based upon that, bits is converted signals to destination bits. Now, remove headers and trailer, packet. Remove network header, segment. Remove transport header, session layer, presentation, decryption and encryption, application. So this is a process in the real time also happening, data flow from device to device. It's clear? Right. Let me continue with next scenario is device 1, device 2, device 3. Three devices are interconnected with switch. Cables, RJ45 cables are connected. This is we call network, right? This is one network. Now for this network, I have assigned IP address in class C example 1.10, 192.168, 1.20, 192.168, 1.30. So what is the network ID here? 192.168, 1.0 is the network ID. Right. And again, you have one more device, and again here three devices there. Even this device also interconnected with switch, RJ45 cables. And for these devices, I'm using the network is 192.168, 2.10, 2.20, 2.30. Says another network. Then what's the network ID? 2.0. My question is here, first network 1, all three computers can communicate each other? Yes, they can. Why? Because all are in what? Same network. And second network, three computers can communicate each other? Yes, they
No.
can, because of they're in what? Same network. But network 1 users, network 2 users, can they communicate?
No,
No. Why?
there is no.
They are in what? Different logical
Different
network, right?
networks.
Yes. But now still you want to enable communication between these two networks, then what we going to do?
We have to add router to the
So now we require what here?
router.
Router is required. So that is our topic now, introduction to routers. So we have an idea where router is required. So what is that? Whenever the traffic is communicating between the different networks, then router is required. So router is a device which enables communication between two or more different logical networks. This is one of the point about router. Tell me a few points about router. Whatever you know about routers, tell me.
Layer 3 device.
Very good. What is router? Router is a layer 3 device. Okay.
Control the traffic.
Control the traffic? No, controlling traffic is a firewall, right?
Yeah.
I'm talking about router. Router is a network layer device. It's a layer 3 device, right? What router will do? It's enable communication between two or more different logical networks. So router is an inter-networking device. It's connecting two or more different network. Means what? It's a inter-networking device, right? Yeah. So these are the points here in the introduction. Router is an internet-working device. It's enable communication between two or more different logical networks. It is a layer 3 device. It's network layer device. So router will find the best path to reach a destination, right? So it's finding the routes. So the word is came from route. Hence it is also find the best route for the networks. The last important point is IP of the router is default gateway for all devices in LAN. What is that point?
Any traffic that's coming out of that network will fall onto this router. Gateway.
Okay. Yeah. Yeah. Let me go back to our diagram here. So to enable communication between these network A and network B, we need a routers, right? How many routers are required here? One or two? It depends upon where your network is being located. If network A is in Hyderabad, which is my head office network. Now network B is in a different location, is my branch 1, in Bangalore. Then how many routers are required? Two routers. One for Hyderabad office and one is branch office, right? Yeah, let me use here R1 for head office, R2 for branch office. Now R1 and R2, they are connected to via internet. So how they are connected, we'll see later. Connect to internet. Okay, now listen carefully. Scenario is here now. In network A, first user is trying to communicate with third computer. I repeat once again. First computer is sharing some data to third computer. So which one is a source device? Which one is the destination device here?
1.0 is, I mean, the first one
First
is the
computer
source.
is
D1 is
a
source, D3 is
One is the
destination.
source, and third is destination.
yeah. So what do you mean by source is where request is started, where a data traffic is started initiated. That is a source device we call it. Where the request ends, that is what destination, right? Yeah. So from source side, data traffic is generated. What is the traffic IP packet contain source IP and destination IP? Source IP is 192.168.1.10. And what is the destination IP now? 192.168.1.30 along with your segment, which is data traffic. Say some IP packet is being generated in first computer. Computers also intelligence. Like computer has very intelligent actually. What computers will do? Before forwarding, before sending to the network, what your PC is doing is your PC itself will check source IP, destination IP, both are in same network or different network. Your PCs will check it. PC is going to check source address is 1.10. My destination is also 1.30. So my destination is not in a different network. My destination is what? Same network. So whenever your PC will feel like destination is in a same network, then the packet will come to switch and switch will send to destination device. So this is how they can internally can communicate. So traffic will not come to outside actually now because of destination is what? Same. This is not exactly my scenario. So if my scenario is a head office first computer is communicating with a branch office one first computer. Yes, because they can communicate, right? Because we have the routers is available, they can communicate different network also. Now source is 1.10, then what is the destination? 2.10. So data traffic is generated. So what my PC will understand now? My computer IP is 1.10 and my destination is a 2.10. Oh, so destination is in a different network. Like PC don't know how to enable different network communication. So now my PC is looking for a router. Like I don't know how to enable different network communication, but I need a router to forward the traffic to outside. So where is router here? And how your PC will understand a router address is, that is the point here. IP of the router, IP address of router. So whatever the router IP address. So generally we used to assign first valid IP address is the router IP address. 192.168.1.1 first usable address is router IP. So whatever IP address you have assigned to router, that address I'm telling to my PC. So PC, if you feel your network is a different, your destination is a different network, then you send your packet to my address. So my address is this 192.168.1.1 as a default gateway. Your gateway is this address. You send to this your traffic to this address. I'll take care about to forward it. PC2, same default gateway. PC3, same. So for all LAN users to go outside, have a common gateway is what? Router. So that is the point here. IP of the router is default gateway for all devices in LAN. It's clear?
Yes.
Yeah. So next point number 2. Type of routers. So basically have a two type of router, software and hardware router. So software routers are, it's just a router feature. It is not a dedicated routers. So software routers are like a Windows server, like Linux server. These are software routers. So software routers will do only different network communication, but they don't have a mechanism of best path selection, routing protocols. That is not dedication actually. It's just a option of router. So we are not going to not working with the software routers. We require the knowledge on dedicated routers or what? Hardware routers. So hardware routers are specially designed for routing algorithms to implementation. In hardware routers also there are so many vendors in the market. Like I have listed here few vendors: Cisco, Juniper, Multicom, HP, D-Link, Maipu, and many more vendors in the market. Software routers are Microsoft Server and Linux Server. These are software routers. So in our training program, we are going to hands-on with hardware routers in Cisco brand. Next point is functions of a router. Point number 3, router functions. What router will do? Anyone can please explain me the internet connectivity for your homes generally, how you are internet connected? So we use this device, right? Yeah. This is your device 1, device 2, device 3, and device 4. And these devices are using private network, which is 192.168.1.0 because of your local network LAN. Your destination is a public domain. Like you are trying to communicate with some fb.com. So this fb.com IP address, let's say 18.1.1.1. So our LAN users are in a 192.168 network and your destination is what 18. network. So what router will do? The first point about router is inter-network communication. Means it's enable communication between two or more different networks. That is inter-network communication. Which device functions you are discussing now? Functions of a router, right? Router will. Best path selection, like from your service provider to reach a Facebook server, have the multiple paths. Best path selection. The next is the packet switching and packet forwarding. What is the packet switching and packet forwarding? Let's say here in your local router, your home router, the backside we have a different type of ports you're seeing, right? So first four are in yellow color. The one which is in a gray one. So the yellow color ports we call it is LAN ports. The one which is in different color, which is gray color, that is what? WAN port. LAN and WAN ports is there in router. LAN ports are connected to users and devices. LAN port 1, LAN port 2, LAN port 3, they're connected. And from service provider cable, like what the cable is coming from ISP. So that wire, where we used to connect? LAN port or WAN port? You can connect it to WAN port to your router. In ISP side, in ISP also they're connected to WAN port, ISP router WAN port. So ISP is directly connected to Facebook server? No. Like this is ISP A connected to ISP B. The WAN ports, or WAN ports. ISP B to Facebook server. Or maybe ISP A to ISP C. ISP C to ISP D. So ISP D is connected to Facebook server. The first point is inter-network communication. Communication between two or more different networks. 192.168 network and 18. network, two different networks. Second point is best path selection. Like from ISP A, how can reach to Facebook server? We can go via ISP B to Facebook or ISP A to C, ISP A to C to D, D to Facebook server. So we have the multiple routes is there. Then what router will do? ISP router will find the best path, shortest path. But the point is, what is the packet switching and packet forwarding? Means from LAN users, end users, data traffic is being generated, right? So this data traffic will come to which port of the router? LAN ports. Because of device are come to LAN ports. Now what your LAN ports will do? What the data traffic is coming from end users, your LAN port will send traffic to which device, which port? WAN port. So LAN ports will not send to ISP router, right? Like LAN port has to send the data traffic to which port? WAN port. So this process we call packet switching. So packet switching means sending IP traffic from one interface to another interface within a router. One port to another port means LAN port to WAN port. This is happening within the router, right? So this process we call packet switching. Okay, packet switch. LAN port 1 switch to WAN port, LAN port 2 switch to WAN port. Like all LAN ports are being switches to WAN port. Now what WAN port will do? Like WAN port is connected to ISP router, right? So it's a home router. So home router will send, WAN port will send the traffic to all the traffic to ISP. Means here, a traffic is going from one router to another router. Means home router to ISP router. So this process we call packet forwarding. Packet forwarding. Packet forwarding is one router to another router. Packet switching is a one interface to another interface within a router. Now what ISP will do again, like WAN port to WAN port, ISP WAN port to ISP WAN port, switching, packet switching. Now ISP A maybe will send the traffic to B or will send the traffic to C. It depends upon the best route. Let's say best route is ISP B. So ISP A to ISP B, packet forwarded. Again ISP B to ISP B, like packet switching, ISP B to Facebook server, packet forwarding. So entire communication has been happening based upon packet switching and packet forwarding. So this is your on office network. Then you are the network engineer. Then what is your responsibility? So this network team has to be monitor always all the routers is doing the job or not. Means what? Packet switching or forwarding. If any one of the route is not packet switching or packet forwarding, why it is not packet switching, any port issue, any IP problem, any protocol problem, that's something we need to be find out and we need to be fix it. So finally have to make sure all routers should be do what? Packet switching and forwarding. Then communication has been enabled. It's clear? This is packet router functions. Yeah. Next point is about types of routers. Point number 4. Types of Cisco router. Two types is it. One is fixed router. Modular router. Fixed router and modular router. What is the difference between fixed router and modular router? Let's consider this is a fixed router. This is modular router. And fixed router LAN port. Fixed router LAN port type is a AUI port. Attachment unit interface. AUI. This AUI port is in a 15-pin port. And this AUI port maximum can support 10 Mbps speed only. So means if you have the fixed router, your LAN port maximum can support 10 Mbps. Like want to upgrade to 100 Mbps is not possible because of the speed is fixed. Why fixed router? So fixed router means the name itself is telling us what? Fixed. Ports are fixed, speed is fixed. In case of modular router, we can modify that. So modular router LAN port types are RJ45 types. Means Ethernet port is available and fast Ethernet ports, gigabit ports. Based upon a requirement, we can change, we can upgrade. Okay, this is the first difference. And second difference is WAN ports. WAN port is nothing but serial port. Serial ports. Maximum number of WAN ports are 2 ports in fixed routers. So WAN port 1 and WAN port 2. From WAN port 1, we can connect it to your branch office 1. I connect it. For WAN port 2, connect to branch office 2. Okay, connect it. Consider this your router is a head office. So from one office, maximum how many branches you can connect with the help of a fixed router? Only 2 branches you can connect, right? Branch 1, branch 2, because of maximum is 2 WAN ports. In case of modular router, based upon our requirement, we can add more. Like WAN port 1, WAN port 2, WAN port 3, WAN port 4, WAN port 5, 6. Like number of WAN ports we can be add. Because of modular routers, slots will be available. In the slots we can add your WAN cards. We can add. Okay. If any one WAN card is not working, you can remove it. You can replace with another new one. Yes. So here the ports are integrated to the motherboard, but here it is not integrated actually. You know, there's a major difference between fixed router and modular router. Alafi, can you hear me?
Yes, sir. Yes,
Yes.
sir.
Yes.
Okay. So finally, in a single point, what is the difference between modular router and fixed router is fixed routers are non-upgradable. Modular routers are upgradable based upon a requirement. We can upgrade LAN port, we can upgrade WAN port also. So which is the best one, fixed or modular?
Modular.
So fixed routers are completely outdated. No more in the market now. I have explained this to understand actually. So now we are working with modular routers. Can you find out this router is a fixed router, modular router?
Fixed router. AUI.
Yeah, AUI port is a, so this port maximum can support 10 Mbps speed only, and it is 15 pin port, and moreover maximum number of WAN ports are 2 ports, which is serial 0 and serial 1. You know, if it is serial 0 is not working or you want to upgrade, we cannot remove it because of the port is integrated to motherboard. But is the modular routers are not integrated actually. You know, we can remove it. This is a slot. We can remove and we can replace with another one. We can insert. Like these cards are removable cards. In the modular routers, like all LAN and WAN cards are what? Removable. We can remove it and we can add it. We can replace the new one. In fixed routers, the ports are integrated to motherboard. Okay. Next, Cisco router categories. Point number 5. Cisco router category. So how many models, what is the categories in Cisco? I'll explain it now. Have a home network. Hardly 5 to 10 devices will be there. Now 5 to 10 devices also reach internet. Do we need a router for the home network? Yes or no? Yes, required router for home networks, right? Yeah. And have a small office. This is not a home network, it's office. Small office. This office means maybe, let's say small office means consider there will be 30 to 50 devices. Now 30 to 50 devices also required internet to processing. Then for small office also required router or not? Yes. Router is required for small office also. And what for branches? No, branch offices means head offices, branches. So one of the branch in Hyderabad, one of branch in different. So like we have some branches, like branch offices consider it as a 100 to 150 devices. Yes. These all users, these all branch office should connect to head office. To connect that, we require a router. Okay. What about head office? Yeah, even head office also, like there will be like complete building is a office. If you take example of banks, a complete building, one building is what? Bank, right? So they also require a router. There will be like 500 to 600 users will be there. They also require router. And all branch 1, branch 2, branch 3, 4, 5, all branches are connected to head office. So to manage the branch also required router. And service provider, even a service provider also required a router because of service provider, like a lot of customers are connected to service provider. Your home network is connected to ISP, small office connected to ISP, branch office, head office via ISP. Like service providers are maintaining a lot of customers traffic, so service provider also required router, right? So these all are wherever network is there. It can be home network, it can be small network, it can be medium network, whatever. Wherever network is there, they require a router, guys. Yes. Yeah. So Cisco started to manufacture to supply the routers for ISP. You require a router, right? Because of we have a lot of customers to maintain the traffic. So based upon your point of view, our Cisco engineers is being developed one router which is recommended to use for service provider type of networks. So that is ISP router. So Cisco has one of the categories what? So only Cisco engineers is being designed for, so which is recommended for use for service provider type of networks. And the Cisco engineers is being developed like manufactured one more type of category router, which is specially designed to use for head office. Head office, you need to maintain all branch traffic, and you have a large number of equipments, number of devices is there, right? So then based upon head office type of networks and Cisco engineers, they have specially designed head office type routers, like branch office type routers. So based upon usage of branches, small, 100 to 150. So you also require router, but you don't require that much of capability of ISPs on head office. You have a small, right? Then Cisco engineers has developed one type of routers. So Cisco router categories are branch router, network agent aggregation router, and service provider router. So branch routers are used for branch offices. Network agent aggregation routers are used for head office, camp offices. Service provider routers, ISP routers. So these are the basic majorly Cisco router categories. Now, what about your home networks and small offices? So Cisco initially they is focused on ISP, head office, and branches only. Commercial, very commercial, enterprises network. But other vendors have been focused on home networks. Like we are very familiar with the D-Link and the Netgear, TP-Link, this type of devices, right? Which is very famous for home networks. But nowadays, here homes also become very smart. Homes also become very smart and require the security also. Then Cisco started to providing routers for home office and small office also. So one type of category is SOHO, small office, home office routers. So SOHO category, branch office, head office, and ISP routers. But how we can find out which is a branch router, which is a network edge router, and which is a service provider router is based upon the model number series. So these all are branch router and its models and series, like 2600 series and 2800, 2900. The models are 2610, 2811, 2611. So there are model numbers. Okay. The next category is
Which is
head office.
using.
Yeah.
Balu, now which is using?
Where? For branches or
Yeah,
head offices?
branches and head offices. So
Yeah, it depends upon usage. It depends upon where you require a router. You need it. You need a router for homes, or do you need a router for branches, or do you need a router for service provider? If you need a router for branches, I mean branch offices, then you can use 2800 series.
oh,
Nowadays,
okay.
you're using 2800, 2900 series. If
Mhm.
your requirement to use in the head offices, then you can use a 5000 series, 5500, 5000 series routers, like that.
Oh, but here it is not there, right? 5000 series.
This is only for branches. See the first line, routers used by small organizations and branches.
Yeah.
These
Mm.
models.
Oh,
Why?
okay.
Because these routers are specially designed like have a slot one, slot two, or one, two, three. Like limited ports is will be there. We can add, we can remove if it's not working. Flexibility is there. Modification
Yeah.
can done, but some limit is there. And the processing capability is a very low processing power. The storage is also very low processing. So that is why these devices recommend to use for small offices, branch offices. So what if you have a large organization like head offices, camp offices like that? Then Cisco recommended to use like 1000 series router, 5000 series router, and 5500 because of here we can add more number of WAN port, LAN ports, whatever. Here we have number of slots is there, and internal processing capability is very high processor, and storage is good. Like and processing speed is very good. Like router port speeds is a gigabit ports, fast Ethernet ports will be there. So then this router is type of routers recommend for what? Head office. The series 5000, 5500, 5508 like this.
Okay. Good.
The next category is a ISP, service provider routers. It is very high-end core router. You know, in very high expensive compared to other vendors. It's very, very high expensive guys actually, you know. So 6000 series or 9000 series. Like the ports are uh, gigabit ports and 10 gig ports, 20 gig ports, optical fiber ports. It's very high-end ports is there. And internally, processing power is very high-end core processors. And router performance is very high performance. And storage capability and the port speed. And internally, power supplies, there will be multiple power supplies. Redundancy power supplies will be there. If any one power supply is down, so another power supply will be active. Because of where we use this type of devices for service providers. Service providers who is connected, like lot of customers are connected. If that router is being down, then lot of customers will be raising a complaint. Issue will be happen, right? So service providers they don't take chances actually. So they use what very high-end core router. Then advantage of what it is. So performance is very high-end core processor, and the port speeds are very high-speed ports. And the power supply also the multiple redundancy power supplies. If any suddenly one power supply is down, so without any downtime, so second power supply will come active one. The processing is be there. Okay. So because of nowadays, your service providers are using this type of very high-end routers. That is why nowadays very low prices also we are getting very good internet.
Sorry, in apartments, they will use this type of routers only, means for service provider.
Service provider?
We'll use this type of routers in apartments. For one apartment, they will fix one router, no, top of the building.
No, that is no. That is a junction box. That is a different.
Okay.
No. This is service provider location. In service provider side, they use what? In office,
Do,
service provider office, they use these routers actually.
do they use in data centers?
Yeah, data centers and service provider, of course, yes. These routers will not use in apartments actually, because of these routers are very high expensive, like in 50 lakhs, 60 lakhs, 70 lakhs. So that is ISP junction box. The box is a different actually. So they use some normal ISP switches they use.
Balu, I was having a question. You directly came to routers. You did not speak about switches. You're going to talk about it, or you were just skipping it? Types of
No.
switches.
So once your routing is done, then we'll have a second office of switches actually.
Okay.
Yeah. So have started to router and routing protocols and routing algorithms complete. Once routing is done, then we'll start it with the after 1 week we'll start with the switching classes actually. LAN technologies.
Okay.
And Balu, the storage capacities differ from routers to routers, right? The models.
Yes, of course.
And can you explain the capacity?
Yeah, that is capacity means like your branch router maybe then have 10 Mbps ports. Port speeds 10 Mbps ports or 100 Mbps ports, 10 to 100 Mbps. If it's a head office, 100 Mbps to 1000 Mbps ports. If it's ISPs, there will be 1000 to like 10 gig ports, 20 gig ports, 30 gig ports. So these all are Ethernet ports. And these all are fiber ports, optical fiber ports will be supported actually. And processing speed is a low. And head office's processor speed is very high processing power is what high process. If it's ISP routers, so service provider routers is very high in process. And storage capability, storage like storage is very low memories will be there. And here the storage is good. Here also storage is good. So hardware wise and performance wise, there will be a difference. So this is a capability we can say actually. So we cannot say exactly so-and-so router can maintain 100 users traffic only or 200 traffic only. That exactly the number we cannot exactly say that. So we need to understand the hardware and processing and the things we need to be understand. That's it. Okay.
So the interfaces will be different in routers, right?
Yes.
So there will be like three interfaces and four, thing like that.
Yes. That is what here in branches there is a limited interfaces only. Maximum 4 to 8 interfaces you can use. If it's a head office, we can add more. Depends upon the models. In service providers, we can more number of slots we can be at.
Okay, it depends upon the routers as well, the model as
Yes, model
well.
numbers.
Okay, okay.
Just the categories we
So
have. In each category, we have any different series and model numbers.
so for the redundancy purpose, if the one interface is down, the packet, I mean the traffic will be routed to the another interface, right?
No, not like that. One interface for one branch, one interface to another branch, one interface to another branch, like that. But redundancy purpose, you have to maintain the routers. One router fails, another router.
Okay.
Like this. Right. Now let's see external components of your router. Externally, what type of ports, what type of components is there in router, and where we use this components, this thing we'll discuss now. Point number 6 is external components of your router. Generally, if it is any router, any category, can be branch router, ISP router, or head office, Cisco, Juniper, like any router, commonly we have three type of ports is there. LAN port, WAN port, and admin ports. I purchased one brand new router from Cisco brand, Cisco 2800 branch router. So even this router has what? Three ports, three type of ports. First one, let's consider LAN port. A LAN port type, it can be Ethernet, or it can be fast Ethernet, or it can be gigabit Ethernet, depends upon your series and model number. So if it's 2800 series, consider fast Ethernet port is this. FE, fast Ethernet port. So your LAN port is to connect to your local network. Inside your network, from router LAN port, the cable connect to your switch. This is a switch. And switch to your end user 1, end user 2, like all end user connect to switches. This is our local area network. So LAN port is used to connect your local networks. I'll show you that point here. Yeah, this is LAN interfaces, RJ45 ports. Router has RJ45 port to connect router to LAN. So here showing FE means fast Ethernet. Port number 100, port number 20/1. Like two ports, two LAN ports is there. One LAN port to maintain one network, another LAN port to maintain another network. Like you can to maintain. So speed of RJ45 ports can be 10 Mbps, can be 100 Mbps, can be 1000 Mbps. It's a LAN port. Okay. So now see the diagram, like all interfaces. Like this is a view, front view and back view of your 2800 series routers. In front view, we have a brand, your manufactured Cisco systems, and the series, which series it is, Cisco 2800 series. The USBs and console port, auxiliary port, power on and off, the flash cards. And the back view, the back side we have the LAN ports, fast Ethernet 0/0, fast Ethernet 0/1. So two LAN ports. And here we have slots is there. So these slots we can remove and you can add whatever you want to add here. Okay. So LAN port, and next is a WAN port. WAN ports are nothing but serial ports, where WAN port is connected to outside wide area network to service provider or your branch offices. They're connected to your WAN ports. So WAN ports are nothing but what? Serial ports. Like serial port 0/0, like one or two ports, you know. So WAN ports are two types is there. Normal serial and smart serial. If it's a normal serial, a port is a 60-pin port. If it's smart serial, it is 26-pin port. And what is the difference here? It is, yeah, you can see this one. This is normal serial. And here it is a smart serial says here. Now, what is the difference here? It is. So serial port is used for WAN connectivity. Serial ports are available as 60-pin female connectors and smart serial 26 female connectors. See, difference is here. This is one slot. What is the diagram here? This is one slot. In slot one, how many ports is there? Normally, normal serial is only one port. Normal serial port only one. Pins is 60 pins. But port is what? Only one port. It means you can connect to only one branch. If it's smart serial slot, it considers a slot 2. In slot 2, how many ports is there? Serial 0 and serial 1. 2 ports is there. So in one slot, one port, that is normal. In one slot, 2 ports is there, that is not smart. So in one slot, we can have it 2 ports, means branch 1, branch 2, 2 branches we can connect. Like again, we have one more type of slot. Let's say slot 3, this is high-speed WAN interface cards. Here 1, 2, 3, 4. In one slot, 4 ports is there. See the differences. Normal serial in one slot, only one port. Smart serial in one slot, 2 ports. High-speed WAN interface cards in one slot, there is 4 ports is there. Okay. So for what type of technology you are using, based on that, generally we are using smart serial and high-speed WAN interface card. No WAN, smart, normal actually, outdated. So nowadays you're using what? Smart and high-speed WAN interface cards. And this is high-speed WAN interface cards. Provide connectivity to wide area network. Okay. The next one is admin. So admin ports are 2 type of ports we have in admin. One is console port and auxiliary port. See, when you purchase a brand new router, LAN port status, your LAN port is in a shutdown state. Even your serial port means WAN port is also a shutdown state. So LAN and WAN ports are shut down. Then how we can use to access your router? Via LAN port, we cannot use because your LAN port is shut down. Via WAN port, you want access is not possible because your WAN port is what? Shut down. So if it's a home routers, by default, it is being configured. Default configuration is there in all home-based routers, but in Cisco routers, there is no pre-configured. So there is no IP address and configurations, passwords, nothing. We don't have any configurations. As an administrator, we need to provide the basic configuration. How? So from your PC and connect console cable to console port. Cable is what? A rollover cable, which is specially designed to initial configuration and troubleshooting purpose. Like you want to access the router through console port, then you have to use this rollover cable. Okay. Yeah. So console cable for initial configuration, which is RJ45 port, local administrative port. It is used for initial configuration and advanced troubleshooting. is the cable, console cable. Read this point. Please read this point. Just a minute. If you read this point. Yes. So here it's showing you what most it is the note is what here. It is the most important port and sensitive port, right? What is the most important port means? Out of all the ports in the router, LAN port, WAN port, which is the most important port. Why? If you have a access for console port, I'm telling in real time example, you know, in your office, if any one person has a access to console port, someone is connected a cable to console port, then he will have a full control of that router. So whatever he want to do, he can do that. We can remove the configurations, we can erase the configurations, and I mean, we can if you want to add any configurations and whatever you want to do, you can do that. You can change the passwords, complete a full control of the router for that person. So that is why this port always should be very secured. So most important port. Want to do any troubleshooting also, we can use it actually. So this always should be secured with passwords. And what is a sensitive port? So sensitive port means like you are connecting console cable to console port. They have remote. Again, you're connecting, remote, connecting, removing. Like number of times every day, morning and connecting and evening removing, connecting. Like frequently, number of times if you insert and removing, plug in, plug out. Like if you do, so inside the console cable, console port, there will be very sensitive copper plates will be there actually. You know that copper plates will be damaged. If it's damaged, then no use of the console port. We cannot do troubleshooting actually. So once you connect it and fix it. So console port for what? It is used for, so for first time, when you configure for first time a router, then you use what? Console port, initial configuration and advanced troubleshooting. Then what about auxiliary port? So auxiliary port also for configuration, but remotely. Admin in local. If he's a local admin, they will connect it to console port. See, router is in a customer location and admin in a office. From office room, you want to connect it remotely. Then we use what? Auxiliary port. But auxiliary port you want to use, we require some dial-up modems. The dial-up modems are outdated. So we are not making use auxiliary port. Then how we can remotely can log in? So we have some services called Telnet, SSH. These services we use to remote login. Okay. So these are about external components of routers. LAN interface, and WAN interface, admin interfaces. LAN interface types are what? It can be Ethernet, or it can be fast Ethernet, or it can be gigabit Ethernet. These are all LAN port types. WAN port types, normal, serial, smart serial, or high-speed WAN interface cards. Admin ports, console port, or auxiliary port. These are all external component and uses. Clear?
High-speed WAN Ethernet control ports are the LAN ports.
WAN ports, HWIC,
What means these are
high-speed
all the
WAN interfaces.
these are all 1 gig Ethernet ports or different ports?
No, different ports. Even compared to high-speed WAN interface cards, Ethernet ports are very high speed.
So what will be the physical connectivity for these high WAN port Ethernet ports?
Laser lines you can use RJ11 or RJ45 cables.
Okay.
Serial cables you can use. Yeah. So today we have discussed all about routers, like what is router, types of router, functions of router, type of Cisco routers and fixer router, modular router, categories, external components. The next session will continue with internal components of router. Internal components of router, like inside the router, what type of components is there, and what is the storage devices will be there, RAMs, NVRAM, or motherboard, processor. So what is the inside of router, that we'll discuss in tomorrow's session. Then finally, we can have a very good idea about routers, and we will start doing the configurations also tomorrow. So our regular practicals will be start from tomorrow. Okay. Any doubts? So I request everyone